Hello everybody, this is Dr. G. We are going to go over 2021 for response question number 2 in this video. This is problem number 2. This is a PVA problem. Position, velocity, and acceleration problem in parametric form. For time t is positive, a particle moves in the xy plane with position vector xt, yt, and the velocity vector given here. At t equals 0, the position of the particle is at -2 and 5. Find the speed of the particle at t equals 1.2 and find the acceleration vector of the particle at t equals 1.2. So given velocity vector here, we can directly plug 1.2 in. Velocity component, x component, and y component here. As we know, the speed is the magnitude of the velocity. So we just take the square root. Will give us 1.2715. This is the speed. The acceleration vector, we just need to take the derivative. And we plug t equals 1.2 in. 6.2467 and 0.4051. Just keep in mind, you don't have to take the derivative at hand. You can use your graphing calculator. Change the graphing calculator mode to parametric equation, PAR. And then you can put x1, y1 using your Vx and Vy. And then you can plug in 1.2 directly. The calculator will do it for you, so you don't have to take any derivatives. This is part A. Part B. Find the total distance traveled by the particle over the time t equals 0 and 1.2. As we know, the distance is given by the integration of the speed dt. So in this case, we just need to put 0 and 1.2 in. Square root Vx squared plus Vy squared dt. Plug this into our graphing calculator. Give us 1.0098. Let's look at part C. Part C, find the coordinates. That means x and y values of the point at which the particle is farthest to the left for t is greater than 0. And explain why there's no point at which the particle is farthest to the right. So let's have a look at the motion of the particle. So this is x-axis. We are going to study on to the left and to the right. So the y value in the y direction, we don't have to worry. So this is at x equals 0. At t equals 0, the particle, the x value, t equals 0, x equals -2. This is at t equals 0. And we know the velocity in the x direction at t equals 0 is negative. That means the particle is moving to the left. When v of x reaches 0, we plug v of x in, we get t equals 1. That means from t to 0, when t reaches 1, the velocity of x reaches 0. And when t is greater than 1, velocity will be positive. So the particle will go back to the right. That's why when t equals 1, the particle will reach the farthest left. Now we want to find the coordinates of the particle at t equals 1. So at t equals 1, x1 equals x of 0 plus 0 to 1 vx dt. Y of 1 equals y0 plus integration 0 to 1 v of y dt. We plug all the values in, -2, this is 5. So use our calculator. This gives us -0.6035. This is 0.4105. So our x coordinates and y coordinate is right here. So the coordinates will be -2.6035 and 5.4105. And explain why there's no point which the particle is farthest right. As t is greater than 1, v of x is positive, means it will keep moving to the right. So there's no farthest point to the right. That's it. So if you have any question with the graphing calculator part, especially in part 1, please let me know.